September 24th, 2025. A solar storm carrying the power of 1 trillion atomic bombs hits an interstellar visitor. What happens next breaks physics. Instead of being destroyed, 3I/Atulus absorbs it every ounce of that apocalyptic energy and converts it into signals aimed directly at Earth. Its brightness jumps exactly 40 times. Not randomly, deliberately. Then scientists calculate its mass 33 billion tons, denser than a neutron star, yet leaving no gravitational trace. Something out there just demonstrated technology we can't explain, and it's studying us. Before we go further, if mysteries like this keep you up at night, subscribe and hit the bell, but only if you mean it. And tell me, where are you right now? And what time is it? I'm curious who's joining me on this journey. Alright, lights down. Volume up, let's find out what really happened when something massive hit 3I/Atlas. Let me take you back to where this story truly begins, not with quiet observations through telescopes, but with violence on a cosmic scale. Picture this, it's September 19th, 2025 and 93 million miles away. The surface of our sun is having what you might call a very bad day. A massive section of the solar corona that's the sun's outer atmosphere suddenly erupts. We're talking about billions of tons of superheated plasma being hurled into space at over 1000 kilometers per second. That's roughly 2.2 million miles per hour. If you're keeping track, this is what scientists call a coronal mass ejection, or CME, and they happen more often than you'd think. The sun throws these cosmic tantrums regularly, spewing magnetized plasma into the void like an angry toddler flinging spaghetti. Now, here's where it gets interesting. NASA's Space Weather Prediction Center had been tracking this particular CME since the moment it erupted. They'd run their sophisticated computer models, crunched the numbers, and concluded what they usually conclude: this storm would pass harmlessly through empty space, missing all the major players in our solar neighborhood by comfortable margins. Mars safe. Earth not even close. Just another solar burp destined to dissipate into the cosmic background. Except there was one thing those models didn't account for. One object that wasn't supposed to be there. 3I/Atlas. 5 days later, September 24th at exactly 14:37 Universal Coordinated Time. To be precise, that trillion atomic bomb punch of solar fury slammed directly into the interstellar visitor. And what happened next? Well, let me put it this way. If you'd asked any astrophysicist what should happen when a CME hits a comet-sized object, they'd give you two options. Option 1, complete vaporization. We're talking instant annihilation. The object turned into a cloud of ionized gas before it even knows what hit it. Option 2, the CME flows around the object like water around a rock in a stream, with minimal interaction. Those are your choices according to every textbook, every computer model, every bit of physics we've accumulated over centuries of studying space. 3I/Atlas chose option 3, Doctor. Sandra Martinez was on shift at the National Solar Observatory when her instruments started going absolutely haywire. She'd been a heliophysicist for 17 years, someone who studies the sun for a living, and she'd never seen readings like this. Instead of being destroyed or swept aside, 3I/Atlas appeared to be doing something that made her question whether her equipment had suffered a catastrophic malfunction. It was absorbing the energy. Not just absorbing it, channeling it, managing it, like catching a cannonball and calmly redirecting its force. The object's brightness began to climb, and climb, and climb. Within 4 hours and 17 minutes again, we're talking precision timing here. 3I/Atlas had increased its luminosity by a factor of exactly 40, not 39, not 41, exactly 40 times brighter. Now, I want you to really think about what exactly means in this context. When natural objects interact with solar storms, they don't increase their brightness by precise multiples. Nature is messy, chaotic, unpredictable. You might get a 27-fold increase, or maybe 53-fold with lots of fluctuation and irregularity, but 40.0. That's not nature, that's engineering. Doctor, James Thompson at Princeton University had dedicated his entire career to studying how plasma interacts with planetary magnetospheres. 30 years of research, hundreds of published papers, textbooks with his name on the cover. When he saw the data from the 3I/Atlas collision, he wrote something in a classified report that would later leak to the press. His exact words, "The object appears to have actively managed the CME encounter." This level of electromagnetic field manipulation requires technology that exceeds our current understanding by orders of magnitude. Let that sink in for a moment. A Princeton physicist, someone who's supposed to explain cosmic phenomena using known physics, basically said, "I have no idea how this is possible." But it gets better. Or worse, depending on your perspective. Radio telescopes around the world, from the National Radio Astronomy Observatory to amateur setups in people's backyards, all detected something during those 4 hours. Structured electromagnetic emissions, not the random noise you'd expect from a comet being bombarded by solar plasma. These were organised, patterned, deliberately constructed signals. Doctor. Alan Foster at the SETI Institute, the guy whose literal job is searching for alien transmissions, found himself making an announcement he'd spent his entire career hoping to make. The signal structure demonstrates mathematical precision, information density, and encoding sophistication that indicates advanced technological intelligence. Think about that for a second. The SETI Institute has been listening to the cosmos for decades, analysing billions of signals, hoping to find just one that shows clear evidence of artificial origin. And here it was, not hiding in some distant galaxy, but happening right here in our solar system, in real time, being broadcast by an object we could actually observe. The signals weren't being scattered randomly into space, either. Oh no. Careful analysis of the transmission patterns showed they were being deliberately beamed toward Earth. Some components seemed to target specific geographic regions, major population centres, advanced research facilities, critical infrastructure. Dr. Maria Santos at UC Berkeley published an analysis that sent chills through both the scientific community and military intelligence agencies worldwide. She wrote, "The transmission patterns correlate strongly with global population density and electromagnetic signatures from major urban centres. This appears to represent systematic reconnaissance rather than an attempt at peaceful communication." Read that again. Systematic reconnaissance. Not hello, we come in peace. Not greetings from across the stars. But reconnaissance, information gathering, cataloguing. Here's what really keeps me up at night, though. The energy management, to absorb a coronal mass ejection to actually harness that apocalyptic amount of power and convert it into controlled, directed signals requires technology operating at levels we can barely conceptualize. We're talking about the energy equivalent of thousands of nuclear power plants being captured, processed, and utilized in real time. Where does that energy go? What's powering these systems, Doctor? Robert Kim at Stanford ran the calculations. Just maintaining the controlled absorption process would require energy output comparable to a small star. Yet 3I/Atlas did it casually, almost effortlessly, like it was the most natural thing in the world. And perhaps most disturbing of all, the collision seemed to enhance the object's capabilities rather than damage them. New structural formations emerged during and immediately after the CME encounter. Amateur radio operators reported detecting entirely new categories of signals that hadn't existed before the collision. It was as if 3I/Atlas had used the solar storm not as something to survive, but as something to harvest, like pulling into the gas station for a refill. You have to wonder, was this intentional? Did 3i/Atlas deliberately position itself in the path of that CME? Because here's the thing, that solar storm was predictable. Space weather forecasters knew it was coming days in advance. If an object possesses the technology to manage electromagnetic fields on that scale, it almost certainly has the capability to predict solar weather patterns. What we witnessed on September 24th wasn't an accident. It was a demonstration, a flex, if you will. Something out there wanted us to know what it was capable of. And judging by the 33 billion ton gravitational impossibility, that is 3i/Atlas, what we saw might just be the warm-up act. But before we dive into that particular nightmare, there's something else you need to know. Something that makes this whole situation even stranger. Because while NASA and major observatories were scrambling to understand what their instruments were telling them, a network of amateur astronomers, regular people with backyard telescopes and a passion for the night sky, had already figured out that something was very, very wrong with 3i/Atlas. And they'd been trying to sound the alarm for weeks. Which brings us to one of the most fascinating and frankly embarrassing aspects of this entire story. The people who saw it coming weren't the ones with billion-dollar budgets and access to the world's most powerful telescopes. They were amateurs, hobbyists, people who do this for the love of it, not the paycheck. And they beat the professionals by weeks. Let me introduce you to Marcus Rodriguez. By day, he's a software engineer in Tucson, Arizona. By night, he's one of the most dedicated amateur astronomers you'll ever meet. His backyard observatory, and yes, I said backyard, cost him about as much as a decent used car. We're talking maybe $30,000 worth of equipment, which sounds like a lot until you realize that some of the professional telescopes we're about to discuss cost more than entire neighborhoods. Marcus had been tracking 3i/Atlas since early July 2025, back when most professional astronomers were still treating it as just another interesting interstellar visitor. Nothing special, nothing urgent, just log the observations, add them to the database, move on to the next project. But Marcus noticed something that the professionals, with all their sophisticated equipment and peer review processes, somehow missed. The object was changing, not gradually, over months or years the way comets typically evolve as they approach the sun. I'm talking about changes visible from one night to the next, structural modifications that shouldn't be possible for any natural object. On the night of August 12th, Marcus captured an image that made him check his equipment 3 times. He thought his telescope was miscalibrated. Then he thought maybe atmospheric distortion was playing tricks on his camera. Finally, after ruling out every technical explanation he could think of, he did what any reasonable person would do. He posted his findings online. Something's growing on this thing, he wrote on the Amateur Astronomy Forum. And I'm not talking about a normal coma development. There are geometric structures emerging from specific points on the surface. They're symmetrical, they're organized, and they're appearing way too fast to be natural sublimation. The response from the professional community crickets. Or worse, polite dismissals. Atmospheric artifacts, they said. Imaging errors. Overinterpretation of low-resolution data. One particularly condescending astronomer even suggested Marcus might want to recalibrate his equipment and perhaps take a refresher course in cometry physics. That astronomer probably regrets that comment now. But here's where it gets beautiful. Marcus didn't back down. Instead, he did something that would change everything. He organized a global observation network. Within 72 hours, he had amateur astronomers from Chile to Australia, from South Africa to Canada, all pointing their telescopes at 3i/Atlas and sharing their data in real time. No institutional bureaucracy, no peer review delays, no academic politics. Just raw, immediate collaboration, and they all saw the same thing. The 3I/Atlas was actively constructing something. Then came Carlos Mendez. Now, Carlos is a legend in the amateur astronomy world. The guy lives in Chile, in the Atacama Desert, which, fun fact, has some of the clearest, darkest skies on Earth. Professional observatories pay millions to build facilities there. Carlos just happens to live there and has turned his property into what he calls my little slice of the cosmos. On September 3rd, Carlos captured something that would break the internet clear. Undeniable footage of what scientists would later call the anti-tail anomaly. And before we go any further, let me explain why this is absolutely bonkers. When comets approach the sun, they develop tails. You've probably seen pictures, these beautiful glowing streams stretching across the sky. Those tails always point away from the sun because solar radiation pushes the dust and gas outward. It's basic physics. It's predictable. It's been that way for literally billions of years. 3I/Atlas's tail was pointing toward the sun, not just sort of angled toward it, not kind of in that general direction, pointing directly at the sun, like someone had reversed the laws of physics just with this one object. Carlos's time-lapse photography showed this impossible configuration, maintaining itself over hours, constantly adjusting, actively resisting the solar wind that should have been blowing it in the opposite direction. He posted the footage on YouTube with the title, "I've been imaging comets for 15 years. This is not natural behaviour." 20 million views in the first week. 20 million. And suddenly NASA couldn't ignore it anymore. Neither could the European Space Agency, or any of the other institutions that had been quietly dismissing the amateur observations. Because Carlos's equipment, while sophisticated, wasn't classified, his techniques weren't proprietary, anyone with similar gear could verify what he was seeing, and they did. Hundreds of amateur astronomers around the world replicated his observations. This is where the story gets a bit uncomfortable for the professional astronomical community. So bear with me. It turns out that the Hubble Space Telescope had actually observed this same anti-tail phenomenon back on July 21st, more than 6 weeks before Carlos published his findings. The images were clear, detailed, and absolutely conclusive. But those observations had been classified as sensitive information, while authorities figured out appropriate public communication strategies. In other words, they knew, and they didn't tell us. Dr. Jennifer Walsh, the senior imaging specialist at the Space Telescope Science Institute, was the one analysing those Hubble images. And according to leaked communications, she'd been trying to get permission to publish her findings for weeks. "We're sitting on evidence of technology that can manipulate fundamental forces," she wrote in an email to her supervisors. "Every day we delay telling people is a day we lose credibility." She was right. When the truth came out, when people realised that official institutions had been sitting on this data, while amateur astronomers were shouting about it from their rooftops, the backlash was immediate and fierce. Congressional hearings were scheduled. Academic integrity was questioned. Trust in space agencies plummeted. But you want to know the really ironic part? The amateur network that Marcus had organised became more reliable and faster at detecting anomalies than the official channels. By late September, when 3I/Atlas was approaching its Mars flyby, NASA was actually consulting Marcus's network for real-time updates. Not officially, of course. But behind closed doors they were checking his website every hour. The democratization of astronomy had reached a tipping point. For the first time in history, citizen scientists weren't just contributing data to professional research, they were leading it. Marcus's network had evolved into a 24/7 global monitoring system with over 4,000 active observers across 87 countries. They had coverage of the entire sky, round the clock, with multiple redundant observations of every major event. And here's my favourite part of this story. Marcus started live streaming his observations every night. People could watch in real time as he tracked 3I/Atlas, narrating what he was seeing, answering questions in the chat, building a community of curious minds who wanted to understand what was happening in their own solar system. One night, during a particularly interesting observation session, someone in the chat asked, "Marcus, do you ever feel scared watching this thing?" His answer gave me chills every single night. But that's not going to stop me from watching. Because if something out there is studying us, then we need to study it right back. That's what humans do. We look up, we question, we try to understand. And I'll be damned if I'm going to let fear stop us from doing that. By October, Marcus's live streams were pulling in over 500,000 concurrent viewers. His YouTube channel had become the go-to source for 3I/Atlas updates, often beating official NASA announcements by hours or even days. Professional astronomers, the ones who'd initially dismissed him, were now appearing as guests on his streams, trying to regain some of the credibility they had lost. The amateur astronomy community had proven something that institutions are still struggling to accept. You don't need a PhD or $1 billion telescope to contribute to humanity's understanding of the universe. You just need curiosity, dedication, and the courage to speak up when you see something that doesn't make sense. But as empowering as this story is, it also raises a disturbing question if amateur astronomers could detect these anomalies with backyard equipment. What else might professional institutions be seeing that they're not telling us? Because while Marcus and Carlos were documenting impossible tails and geometric structures, scientists with access to far more powerful instruments were discovering something even more troubling about 3I/Atlas. Something that violated not just our understanding of comets, but our understanding of matter itself. And the math on this one, it's absolutely terrifying. While amateur astronomers were busy documenting what 3I/Atlas looked like, a small team of researchers was asking a different question entirely. How much does this thing actually weigh? And the answer they got back, well, it shouldn't exist, Doctor. Richard Kett hadn't slept properly in 3 days. Not because he was excited though he was, but because he kept running the same calculations over and over, convinced he'd made a mistake somewhere. You know that feeling when you check your bank account and see an extra zero that shouldn't be there? That moment of "this can't be right," followed by obsessively recalculating everything. That's where Richard was living. He was working with Avi Loeb and Peter Veers, analysing 4 months of positional data from 227 observatories worldwide. That's 4022 individual position measurements. If you're counting, and what they were looking for wasn't glamorous, they just wanted basic trajectory information. How fast is this thing going? Is it accelerating? Where will it be next week? Except the data wasn't cooperating. See, when objects move through space, they respond to forces. Gravity pulls them around. Solar radiation nudges them slightly. If they're actively releasing gas and dust like comets do, that outgassing creates a tiny rocket effect. These effects are small but measurable. In fact, that's how we figure out what space objects are made of. It's cosmic forensics. But 3I/Atlas was moving like none of these forces existed. The Webb Space Telescope had measured the object losing 150 kilograms per second, that's 330 pounds, every single second being ejected at 440 meters per second. According to Newton's laws, which have worked perfectly for about 340 years, this should create an observable trajectory change. It's basic physics. You throw mass in one direction, you get pushed in the other. 3I/Atlas, 0 deviation, not even a tiny wobble, Doctor. Maria Gonzalez at the European Space Agency put it bluntly, if an object is hemorrhaging 150 kilos per second in non-symmetrical patterns and conservation of momentum doesn't apply, then either physics is broken or we're looking at technology that can violate conservation laws. Translation: either everything we know is wrong, or 3i/Atlas has Star Trek level technology. Richard's team worked through every explanation. Maybe the outgassing was perfectly symmetrical, no observations showed clear asymmetry. Maybe hidden vents were balancing the thrust. They modelled that. Didn't work. Maybe solar wind was perfectly counteracting it that would require impossibly precise conditions. They kept hitting the same wall. The only way 3i/Atlas could maintain its trajectory despite losing all that mass was if it was far more massive than it should be. Stupidly massive. Impossibly massive. The calculation was straightforward, even if the result was insane 33 billion tons minimum. Let me help you grasp that number. The International Space Station weighs 420 tons. 3i/Atlas is 78 million times more massive. The Empire State Building, about 365,000 tons. You'd need 90,000 Empire State Buildings to equal 3i/Atlas. But here's the kicker, the object's maximum diameter is roughly 3.5 kilometers, about 2.2 miles. Some estimates put it smaller, so we're cramming 33 billion tons into something the size of a small mountain. Do the density math, and you get neutron star material. Dr. James Mitchell at MIT was brought in to evaluate if this was even possible. His answer after 72 sleepless hours: no natural substance can maintain such compression outside a collapsed star core. We're looking at density values that require either undiscovered matter states or internal engineering that approaches theoretical physical limits. Think about that. Neutron stars achieve their density because they have solar mass gravity crushing matter until electrons get forced into protons. A teaspoon of neutron star material weighs about 1 billion tons. 3i/Atlas is floating through space with that density, at room temperature, no gravitational collapse. Just existing. But it gets worse. If 3i/Atlas really has that mass, we should see gravitational effects everywhere. Spacecraft trajectories should bend. Nearby asteroids should have perturbed orbits. We should detect its gravitational signature easily. Dr. Sarah Kim at Caltech checked. An object with 33 billion tons should create measurable gravitational perturbations. We analysed 7 spacecraft and 43 asteroids that passed within range. 0 anomalies. None. It's gravitationally invisible. So let me get this straight. 3i/Atlas has the mass of a small moon compressed into a mountain-sized volume. Yet it's hiding its gravitational signature. That's not advanced technology, that's manipulation of fundamental forces. You can't just turn off gravity. Mass warp space-time? That's not theory, that's observed fact. GPS satellites account for gravitational time dilation to work properly. Unless you're 3i/Atlas, apparently, the Pentagon implications hit hard. If something can manipulate gravitational fields, every physics-based defense becomes obsolete. Dr. Kim wrote in a leaked assessment, gravitational manipulation represents ultimate engineering capability. Such intelligence could reshape matter at atomic scales, manipulate planetary orbits, harness unimaginable energy. Traditional defense concepts become meaningless. Picture what gravitational control means. Artificial gravity for space travel, warping space for faster-than-light movement, extracting planetary core materials without mining, moving celestial bodies, or less friendly tearing spacecraft apart with gravity gradients, destabilizing orbits, weaponizing gravity itself. And something with that technology is studying our solar system right now. Doctor. Lisa Park at MIT examined what such capabilities require. Containing exotic matter at these densities needs quantum-scale electromagnetic field control, real-time quantum manipulation, and structural engineering operating from subatomic to macroscopic scales simultaneously. This suggests engineering approaching theoretical physical limits. Not advanced technology, nearly perfect technology, playing at the absolute edge of what universal laws permit. But here's what haunts me, the energy requirements. Dr. Robert Chen at Caltech calculated maintenance needs. Energy density required exceeds anything we can generate or imagine. The object may be accessing energy sources we can barely describe theoretically. He suggested 3I/Atlas might tap quantum vacuum energy, the energy in empty space. Virtual particles popping in and out of existence. Theorists calculate that a coffee cup of vacuum space might contain more energy than all visible stars. Actually harnessing that science fiction, or it was, until now. Remember that coronal mass ejection 3I/Atlas absorbed, now we know why. If it accesses vacuum energy, solar storms aren't threats, they're convenient snacks. Trajectory analysis revealed something creepier, the mass wasn't uniform. Using gravitational microlensing, watching how background starlight bends, researchers found the concentration shifted. Different regions became denser over time, corresponding to where structures were growing. It was redistributing its matter in real time. Amateur radio operators reported something else. After the mass analysis went public, 3I/Atlas signals changed. Frequency increased. Complexity jumped, like it knew we'd figured out its mass and responded by stepping up. Marcus noted during a live stream, "It's testing us. Every time we solve one puzzle, it shows something new. Either it wants us to understand or it's evaluating our intelligence. Neither option is comforting." The scariest part, we detected all this from 277 million miles away, using instruments designed for rocks and ice. Imagine what we'd discover up close. What other impossible physics is it demonstrating that we simply can't detect yet? The 33 billion ton nightmare transformed 3I/Atlas from mysterious visitor to object that violates known physics. And if you think that's unsettling, wait until you hear about the Harvard professor who suggested this wasn't just an object, it was a mothership preparing to deploy probes throughout our solar system. And is math uncomfortably solid? So we've got an object that defies physics, hides its gravitational signature, and seems to know when we're watching. Naturally, someone had to ask the question nobody wanted to hear: what if this isn't the main event? What if 3I/Atlas is just the delivery system? August 5th, 2025. A date that would either go down in history as humanity's greatest moment of foresight, or its most embarrassing false alarm. That's when Avi Loeb, Harvard professor, longest-serving chair of their astronomy department, and the guy who's never been afraid to think thoughts that make other scientists uncomfortable, published a blog post that broke the internet. The title was innocuous enough: Optimal Trajectories for Interstellar Objects. Sounds like a snooze fest. Right, the kind of paper you'd use to cure insomnia. But buried in that clinical, mathematical prose was a scenario that would generate 2 million views in 24 hours and spawn 1,000 conspiracy theories. Loeb wrote, "The more likely scenario from an engineering perspective involves a mothership that releases many probes which perform a reverse Oberth maneuver to slow down at perihelion and intercept Earth." A mothership? He actually used the word mothership. Now, before you write this off as science fiction, let me explain what makes this theory so disturbingly plausible. Loeb wasn't speculating wildly, he was doing what he's always done, following the engineering logic to its most efficient conclusion. The Oberth maneuver is real physics, not Star Trek nonsense. It's a technique we've been using for decades. The basic idea: when you're moving fast near a massive object like the Sun, your engines are more effective. Fire your rockets at perihelion closest approach to the Sun and you get more bang for your buck. It's how we sling spacecraft to distant planets without carrying impossibly large fuel tanks. But Loeb suggested something beautifully elegant run it in reverse. Instead of speeding up, slow down. Release small probes when you're screaming past the Sun at maximum velocity. Have them fire their engines to brake, and use the Sun's gravity to redirect them towards specific targets. In this case, Earth. The math was elegant. Almost too elegant, according to Loeb's calculations. If 3I/Atlas deployed probes during its solar passage, remember that convenient 6-week period when it disappeared behind the Sun? Those probes could reach Earth's vicinity between November 21st and December 5th. 2025. He gave us a deadline, an actual date when alien probes might arrive. Dr. James Harrison at the Jet Propulsion Laboratory, a guy who spent his career designing trajectories for Mars missions, found himself in the awkward position of having to confirm that Loeb's scenario wasn't just possible, but optimal. In a peer-reviewed paper published weeks after Loeb's blog post, Harrison wrote, "If you were designing an interstellar mission to deploy reconnaissance probes in a foreign solar system, this approach would maximize efficiency while minimizing detection risk. It represents elegant engineering that any mission planner would admire." Read that again. A NASA scientist essentially said, yeah, if we were doing this, that's exactly how we'd do it. The timing was perfect or terrifying, depending on your perspective. 3I/Atlas would reach perihelion on October 29th, disappearing behind the solar glare at the exact moment when deployment would be optimal. Any probes released during that window would be completely invisible from Earth, masked by the Sun's overwhelming brightness. By the time we could observe that region of space again, the probes would be long gone, already en route to their targets. It was the perfect operational cover for what military strategists call a covert deployment. Within 6 hours of publication, Loeb's post had 800,000 views. By the end of day one, over 2 million. News outlets worldwide scrambled to interview him. But the professor had gone dark. His university email had an auto-reply saying he was unavailable. His research assistants claimed ignorance. The man had dropped a bomb and vanished. NASA's response was swift and, let's be honest, a bit desperate. Dr. Sarah Mitchell, NASA's director of astrobiology and a longtime colleague of Loeb's, held a hastily arranged press conference. Professor Loeb's speculation goes far beyond what available evidence supports. While we respect his contributions, these particular ideas represent conjecture rather than scientific analysis. But here's the problem with that statement: Loeb hadn't speculated about alien intentions or made wild claims. He'd simply described the most efficient trajectory for an interstellar reconnaissance mission. The physics was sound, the engineering was logical, and everyone knew it. The internet exploded. #alien mothership trended globally with over 10 million posts in the first week. Survival gear retailers reported massive sales spikes. People were buying emergency food supplies, water purification systems, communication equipment. Several major cities saw spontaneous protests demanding government transparency, with signs reading, "Tell us the truth about 3I/Atlas, and we have a right to know what's coming." The scientific community fractured into warring camps. Dr. Jennifer Walsh at the University of Chicago captured the frustration many felt. Avi has always pushed boundaries, and that's been valuable. But this feels different. This feels like he's abandoned scientific caution entirely. Yet the amateur radio community was picking up something interesting. Ham radio operators worldwide started reporting unusual signals that seemed to correlate with Loeb's deployment timeline. Weak, intermittent, but their timing was too coincidental to ignore. Marcus Chen, a retired electronics engineer in New Mexico, recorded signals that he analysed on YouTube, pulling 3 million views. I've been listening to space for 40 years. I know cosmic background radiation, I know pulsars. This is different. This is organised, almost like it's carrying information. When audio specialists analysed his recordings, they found distinct mathematical patterns, prime numbers, Fibonacci sequences, patterns statistically unlikely to occur naturally but perfectly consistent with how human scientists might demonstrate intelligence to alien observers. The government response revealed how seriously they were taking this. Russia's Dmitry Volkov, head of their Institute for Space Research, gave an unprecedented interview suggesting international cooperation should expand immediately. This object represents phenomena no single nation can fully understand alone. We must pool resources and share data. China's National Space Administration, typically secretive, suddenly began sharing detailed tracking data with international partners. The unprecedented transparency raised obvious questions. What had Chinese scientists observed that concerned them enough to break decades of policy? But perhaps most disturbing was Loeb's analysis of what he called the stealth deployment advantage. In a follow-up post that received even more attention, he wrote, "The deployment window provides perfect operational cover. Any released objects would be masked by solar radiation, hidden in electromagnetic chaos. By the time they became detectable, they'd already be wherever their mission required." Think about that. If Loeb was right, humanity might remain completely unaware of probe deployment until the objects chose to reveal themselves. We could have alien surveillance operating in Earth's vicinity right now, and we'd have no idea. Dr. Robert Kim at Stanford analysed this from a game theory perspective. The deployment window's information warfare value is so significant it's unlikely to be accidental. An advanced intelligence planning contact with a younger civilization would understand the psychological impact of periods of uncertainty. Religious communities grappled with implications many had never seriously considered. The Vatican issued a statement acknowledging that divine creation encompasses infinite possibilities, while emphasizing faith over fear. Other leaders saw 3I/Atlas as either divine intervention or a test of faith. Social media platforms struggled with the explosion of content mixing legitimate science with wild speculation. Mental health professionals reported significant increases in contact anxiety fear that humanity was unprepared for what might be coming. But Loeb himself remained mysteriously absent. Colleagues reported he'd cancelled all speaking engagements. His Harvard office stayed empty. Department staff claimed no knowledge of his whereabouts. The disappearance of such a prominent figure only fueled speculation about what he might know that he wasn't saying publicly. Here's what made the mothership theory so unsettling. It wasn't based on belief or hope or fear. It was based on pure engineering efficiency. If you wanted to survey a solar system, this is exactly how you do it. Send a large carrier vessel that can handle the multi-million-year journey. Upon arrival, deploy smaller, specialized probes that can investigate specific targets without risking the mothership. It's literally how we explore other planets. The Mars Reconnaissance Orbiter carries multiple instruments. Curiosity rover was deployed from a sky crane. We use mothership and probe architecture because it works. And if we use it, why wouldn't they? The November 21st deadline was approaching fast. Telescopes worldwide prepared for the most intensive sky survey in history. Military tracking networks went on high alert. Amateur astronomers coordinated 24/7 observation schedules. And everyone from scientists to grocery store clerks found themselves wondering the same thing: what happens if Loeb is right? But before that deadline arrived, 3I/Atlas had one more trick to show us. Something so bizarre, so impossibly beautiful, that it would force even the skeptics to admit whatever this thing is, it's not playing by our rules. And the evidence was written in cosmic dust across millions of miles of space. While the world was obsessing over motherships and deployment windows, a handful of astronomers were staring at images that made them question their sanity. Because 3I/Atlas wasn't just breaking the rules of physics, it was creating art that shouldn't be possible. And when I say art, I mean something that looked more like a deliberate sculpture than anything nature could produce. July 21st, 2025. Dr. Jennifer Walsh had been working at the Space Telescope Science Institute for 18 years, analysing thousands of comet images. She'd seen every variation of tail structure, every quirk of dust distribution, every anomaly that solar wind could produce. So when the Hubble Space Telescope images of 3I/Atlas came across her screen, her first instinct was to assume equipment malfunction. She checked the calibration. Perfect. She examined the imaging sensors, functioning normally. She pulled up archival data to compare. Everything checked out. Which meant the impossible thing she was seeing was actually real. The tail was pointing the wrong direction. Now, let me explain why this made her want to throw her PhD in the trash and become a bartender. When comets approach the sun, they heat up. Ice sublimates turns directly from solid to gas, carrying dust particles with it. Solar radiation then pushes this material away from the sun, creating those beautiful tails we see in photographs. The tail always points away from the sun. Always. It's been that way for literally billions of years. It's one of those things that's so fundamental, so unchangeable, that we don't even question it anymore. 3I/Atlas's tail was pointing toward the sun, not sort of angled in the general direction, not kinda close, directly at the sun, like someone had grabbed the laws of physics, turned them upside down, and said, "Let's try it this way instead." Walsh spent the next 6 hours rechecking everything. She brought in colleagues. They ran every diagnostic test imaginable. Finally, one of them said what they were all thinking: either Hubble is completely broken or that object is actively controlling its dust emissions. The images showed a teardrop-shaped cocoon of dust, but the broader end was pointing toward the sun while the narrow end trailed behind. It looked like 3I/Atlas was collecting dust rather than ejecting it, or more accurately, it looked like something was managing the dust, arranging it into a configuration that defied every principle of solar physics. Here's what makes this truly bonkers: maintaining an anti-tail structure requires fighting against forces that are absolutely relentless. Solar radiation pressure at that distance is incredibly powerful. It's like trying to hold an umbrella steady in a hurricane while running backwards. Except the hurricane is made of light particles travelling at 186,000 miles per second, and it never stops. Dr. Robert Kim at Stanford calculated the energy requirements. To maintain this configuration against solar radiation pressure would require continuous energy expenditure equivalent to a small nuclear reactor. And we're not talking about maintaining it for minutes. The structure remained stable for hours, possibly days. The classified report that Walsh submitted to her superiors was blunt. We are observing dust management that requires real-time force manipulation across millions of cubic kilometers of space. This level of electromagnetic field control exceeds our technological capabilities by orders of magnitude. But here's where the cover-up attempt fell apart spectacularly. Remember Carlos Mendez, our Chilean amateur astronomer with a backyard observatory? On September 3rd, more than 6 weeks after Hubble captured its images, Carlos photographed the same anti-tail structure using equipment that cost less than a used Honda Civic. He posted it on YouTube with brutal honesty. "I've been imaging comets for 15 years. This is not natural behaviour." 20 million views in 1 week. Suddenly, NASA couldn't sit on Walsh's findings anymore. people with consumer-grade telescopes were seeing the same impossible phenomenon that Hubble had documented. The classification strategy collapsed like a house of cards. Walsh was finally allowed to publish. Her paper was careful, measured, academic, but the conclusion was devastating. The anti-tail structure demonstrates selective force management that indicates technological rather than natural processes. No known mechanism can account for the observed dust configuration. The images themselves were stunning. Time-lapse photography showed the structure constantly adjusting, maintaining precise geometric relationships despite the chaos of the solar environment. It was like watching someone carefully balance thousands of plates on sticks, except the plates were clouds of dust millions of miles across, and the wind trying to knock them down was travelling at the speed of light. Dr. Maria Santos at UC Berkeley published an analysis that sent chills through both scientific and intelligence communities. She'd found patterns in the dust distribution, mathematical patterns. The arrangement wasn't random. It contained information encoded in the geometric relationships between different dust clouds. The anti-tail configuration demonstrates organizational principles consistent with information encoding, she wrote. We may be observing a form of communication that uses cosmic dust as a medium for transmitting data across interstellar distances. Think about that for a moment. What if the anti-tail wasn't a byproduct of some propulsion system or navigation process? What if it was deliberate communication? A message written in dust particles across millions of miles of space, visible to anyone with a telescope and the knowledge to look. But here's what really kept scientists up at night: the aesthetic quality. The structure wasn't just functional, it was beautiful, symmetrical, elegant. It showed an appreciation for form that went beyond mere engineering efficiency. Dr. Jennifer Walsh, who'd spent her career studying comets, found herself making comparisons that felt almost sacrilegious in a scientific context. There's an artistic dimension to this that I can't ignore. The way the dust is arranged, the harmonic relationships between different structural elements, it reminds me of classical architecture, like we're looking at the space equivalent of the Parthenon. Religious leaders worldwide grappled with what this meant. Some interpreted the beauty as evidence of divine inspiration working through alien intelligence. Others worried about encountering minds that could reshape matter according to aesthetic preferences that sounded uncomfortably close to godlike power. Amateur radio operators added another layer to the mystery. They reported electromagnetic emissions that correlated precisely with changes in the anti-tail structure. Every time the dust configuration adjusted, there was a corresponding signal burst. The timing was too perfect to be coincidental. Marcus Chen's network documented over 200 instances where dust modifications corresponded with radio emissions within a 2-second window. It's like watching someone paint, Marcus explained during one of his live streams. Each brushstroke accompanied by a specific signal. Either this is the most elaborate coincidence in history, or we're watching active communication and construction happening simultaneously. The energy management implications were staggering. Dr. Lisa Parker, MIT, calculated that maintaining the anti-tail while also generating structured radio signals would require power systems that could operate continuously without any apparent fuel source. We're looking at technology that either has access to energy sources we don't understand, or operates at efficiency levels approaching thermodynamic perfection, she wrote. Some researchers suggested the anti-tail might serve multiple purposes simultaneously: navigation, communication, scientific observation, and aesthetic expression all rolled into one elegant system. It was the kind of multifunctional design that human engineers dream about but rarely achieve. The Vatican's Pontifical Academy of Sciences issued a statement that captured the philosophical vertigo many were feeling. We are confronted with intelligence that demonstrates mastery over natural forces while expressing what appears to be artistic sensibility. This combination challenges our assumptions about the relationship between technology and consciousness. But perhaps most disturbing was the responsive nature of the structure. After the anti-tail became public knowledge, after millions of humans had seen the images and understood what they were looking at, the configuration became more complex, more elaborate, as if 3i/Atlas knew it had an audience and decided to put on a better show, Doctor. Robert Kim analysed this behavioural change. The increased complexity following public awareness suggests the object is monitoring our communications and adjusting its displays accordingly. We're not just observing it, it's observing our reaction to being observed. That's a level of recursive awareness that indicates sophisticated intelligence. The anti-tail had transformed from astronomical anomaly into undeniable proof that 3i/Atlas possessed both technological supremacy and something else, something harder to quantify: intentionality. Awareness, perhaps even creativity, and it was about to give us an even closer demonstration of what it could do. Because on October 3rd, 3i/Atlas would pass within 0.19 astronomical units of Mars, close enough for humanity's armada of orbiters and rovers to watch it work. Close enough to see exactly what this thing did when it investigated another planet. And what we witnessed during those 12 hours would remove any lingering doubts about whether we were dealing with natural phenomena or something far more deliberate. Retry F. Creating impossible art with cosmic dust is one thing, but what happens when that same object decides to conduct a close-up inspection of another planet and we have front-row seats to watch it happen? October 3rd would answer that question in ways that made everyone deeply uncomfortable. Doctor? Sarah Chen hadn't had a full night's sleep in 2 weeks. As Mission Operations Director for the Mars Reconnaissance Orbiter, she was coordinating what she kept calling the most absurdly ambitious observation campaign in the history of space exploration. And she wasn't exaggerating. Picture this 6 active spacecraft orbiting Mars, 2 rovers on the surface, and every deep space telescope on Earth, all focusing on a single target for a 12-hour window. It was like getting every camera crew in the world to film the same scene from different angles. Except the scene was happening 140 million miles away. And the subject was an object that had already violated half the laws of physics. We're either about to witness the most significant scientific observation in human history, Chen told her team during the final prep briefing, or we're about to waste billions of dollars of equipment watching a rock float by. Either way, we're not blinking. The European Space Agency's Mars Express orbiter had been repositioned specifically for this event. Dr. Angela Martinez, the mission's principal investigator, had worked 18-hour days preparing observation sequences. Her high-resolution stereo camera was configured to achieve pixel resolutions of approximately 30 meters across 3i/Atlas's surface. If this thing is scanning Mars, Martinez explained, we'll be scanning it right back. At this range, we should be able to resolve individual structural components. If it's got antennas, sensors, or anything remotely technological, we'll see them. The approach distance was 0.19 astronomical units, roughly 17.7 million miles. That might sound far, but in space terms, that's practically brushing shoulders. It's like the difference between watching someone from across a football field versus across a parking lot. Details matter at that range. NASA's Mars Reconnaissance Orbiter brought the heavy artillery. Its high-risk camera, normally used for photographing Martian surface features in absurd detail, had been reconfigured to track a moving interstellar object. Dr. James Wilson at the University of Arizona calculated they'd be able to resolve features as small as 3 meters across during closest approach. We're going to see individual components, Wilson said, barely containing his excitement. If there are mechanical systems, surface modifications, or artificial structures. HIRIS will document them with unprecedented clarity. This is like going from looking at Earth from orbit to suddenly being able to count the windows on individual buildings. October 3rd, 1400 UTC. The observation window opened. And 3I/Atlas did not disappoint. The first thing that caught everyone's attention was the scanning pattern. As the object approached Mars, those geometric structures, the ones that had been growing for months, began moving. Not randomly, not chaotically. They rotated, extended, and repositioned themselves in systematic sweeps across the Martian surface. Chen watched the data coming in real time, her coffee going cold in her hand. "It's methodical," she muttered to no one in particular. "Look at the pattern. It's covering the entire visible hemisphere in grid sections. That's not natural behaviour. That's a survey pattern." The Mars Express data confirmed it. Spectroscopic readings showed the object was emitting electromagnetic pulses across multiple frequencies radar. Infrared, visible light, even X-rays. Each pulse corresponded to the movement of these surface structures. It was scanning Mars the same way our spacecraft scan planets, actively, deliberately, thoroughly. But here's where it got really interesting. 3I/Atlas wasn't just scanning randomly. It was prioritizing specific targets. The structures spent more time oriented toward Olympus Mons, the largest volcano in the solar system. They lingered over Valles Marineris, that massive canyon system. They paid particular attention to the polar ice caps. Dr. Lisa Park at MIT, who'd been brought in specifically to analyze behavioral patterns, nearly choked on her water when she saw the targeting sequence. This is exactly how we'd survey Mars if we were doing geological reconnaissance. She explained during the emergency analysis session. It's hitting every major feature that would tell you about the planet's composition, history, and potential resources. This isn't casual observation. This is professional survey work. The Chinese Tianwen-1 orbiter captured something that made intelligence agencies around the world very nervous. During a 7-minute window, 3I/Atlas appeared to focus its scanning systems on a specific region near the Martian equator. Not a natural feature, not a geological landmark. The location where NASA's Perseverance rover was operating. "It knows we're there," someone said in the ESA control room. The statement hung in the air like smoke. Nobody contradicted it. The rover data confirmed the worst. Perseverance's instruments had detected a focused beam of electromagnetic radiation hitting its location. The exposure lasted exactly 43 seconds. Not long enough to cause damage, but definitely long enough to gather detailed information about human technology sitting on another planet. Marcus Rodriguez, watching through his backyard telescope and streaming to 800,000 live viewers, caught the moment when 3I/Atlas's brightness spiked. There, see that it just pulsed. That's not reflected sunlight, that's active emission. It's sending signals, probably transmitting data back to somewhere. Amateur radio operators worldwide went into overdrive. The signals they'd been tracking for months suddenly intensified. Structured data packets sent in bursts that corresponded exactly with what the Mars orbiters were observing. Whatever information 3I/Atlas was gathering, it was transmitting immediately. But who was receiving it? That question kept everyone awake. The 12-hour observation window revealed something else that military analysts found deeply concerning efficiency. 3I/Atlas completed its Mars survey in a fraction of the time it would take human spacecraft to gather equivalent data. The systematic coverage, the adaptive targeting, the multispectrum analysis, it was operating at a level of sophistication that made our most advanced reconnaissance platforms look like disposable cameras. Colonel Janet Rodriguez, writing her classified assessment for the Department of Defense, didn't mince words. This object has demonstrated reconnaissance capabilities that exceed our most advanced military satellites by orders of magnitude. Whether peaceful or hostile, those capabilities represent a potential threat that requires immediate contingency planning. Dr. Robert Kim at Stanford analysed the Mars flyby from a strategic perspective and found something chilling. The object's behaviour suggests it's not just gathering scientific data, it's assessing technological capabilities. The focus scan of Perseverance wasn't curiosity, it was evaluation. It's determining what we can do. As 3I/Atlas departed Mars and continued its trajectory towards Jupiter, the scientific community was left processing an uncomfortable truth they'd just watched: alien technology conduct a professional survey of another planet while simultaneously evaluating human presence there. And it had done so with a level of efficiency and capability that made humanity's century of space exploration look like amateur hour. Dr. Sarah Chen, finally allowing herself to sleep after 36 hours of continuous operations, had one final thought before crashing. We just watched it work. We saw exactly how it operates, how it thinks, how it prioritizes targets. And you know what terrifies me? It let us watch. It didn't hide what it was doing. Either it doesn't care that we're observing, or it wants us to know what it's capable of. Neither option is comforting. The Mars flyby had provided answers. Yes, 3I/Atlas was conducting systematic reconnaissance. Yes, it possessed technology far beyond human capability. Yes, it was aware of our presence and actively studying us. But those answers only raised bigger questions, because in just a few weeks, 3I/Atlas would disappear behind the Sun for 6 weeks of complete invisibility. And based on what it had just demonstrated at Mars, everyone was wondering the same thing: what would it do when we couldn't watch? That 6-week blackout was approaching fast. And Avi Loeb's mothership theory, the one about probe deployment during solar conjunction, was starting to look less like speculation and more like prophecy. So we'd watched 3I/Atlas conduct a professional survey of Mars with technology that made our best equipment look like children's toys. Now imagine that same object preparing to go dark for 6 weeks, disappearing behind the Sun at the exact moment when covert operations would be optimal. Coincidence? The math said otherwise. October 29th, 2025. If you've ever lost your phone in your house and spent 20 minutes frantically searching for it, multiply that anxiety by about 1 billion. That's roughly how astronomers felt as 3I/Atlas slipped behind the Sun and vanished from view. Dr. Jennifer Walsh at the Space Telescope Science Institute had been dreading this moment since the first trajectory calculations confirmed it was coming. We're about to lose visual contact with the most significant object ever detected in space. She explained during what would be her final press briefing before the blackout. For the next month and a half, we'll be completely blind to whatever 3I/Atlas might be doing behind the Sun. Now, solar conjunctions aren't unusual. Planets regularly pass behind the Sun from Earth's perspective. Mars does it. Venus does it. We lose contact with our spacecraft orbiting those planets for a few weeks, wait it out, then resume operations. It's routine, predictable, no big deal, but 3I/Atlas wasn't routine. This was an object that had spent months demonstrating technological capabilities that violated known physics, conducting systematic reconnaissance, and apparently monitoring human reactions to being observed. And it was about to spend 6 weeks operating with complete privacy. The timing was too perfect. Remember Avi Loeb's mothership theory? He'd specifically identified perihelion passage closest approach to the Sun as the optimal moment for deploying reconnaissance probes. His exact words haunted every conversation. The solar blackout provides perfect operational cover. Any released objects would be masked by overwhelming electromagnetic interference. By the time they become detectable, they'd already be wherever their mission requires them to be. Doctor. Sarah Kim at Caltech had been modelling what 3I/Atlas could accomplish during its hidden passage. Her scenarios kept defence analysts awake at night. The blackout provides ideal conditions for any activity the object prefers to keep private. She wrote in a report that was immediately classified. Probe deployment, trajectory modification, system upgrades, reconnaissance activities, all completely invisible to Earth-based observation. Here's what made it worse. This wasn't just visual blindness. The sun is essentially a massive radio jammer. It puts out so much electromagnetic noise across so many frequencies that detecting subtle signals from behind it is nearly impossible. Radio telescopes could maybe pick up the strongest transmissions, but anything subtle would be completely lost in the solar static. NASA's Planetary Defense Coordination Office found itself preparing for threats no protocol had anticipated. Dr. Angela Martinez, coordinating the European Space Agency's response, put it bluntly, "We're attempting to monitor an object that may be smaller than a city block, travelling at interplanetary velocities, using technology that exceeds our understanding, hidden behind a star that's 865,000 miles wide. Our detection capabilities are fundamentally inadequate." The space agency did what it could. Deep space monitoring networks were reconfigured. Radio telescopes worldwide were repositioned to listen for any signals that might leak around the edges of the sun's electromagnetic interference. Several satellites were repositioned, burning precious fuel that would shorten their operational lifetimes to maximize any possible observation opportunities. Russia's Roscosmos made similar preparations. Though most remained classified, leaked communications suggested Russian scientists were particularly concerned about trajectory modifications. If 3I/Atlas changed course during the blackout, it would confirm beyond doubt that the object was under intelligent control. China's National Space Administration shared detailed predictions about when the object should reappear if it continued its current trajectory. The calculations provided a timeline the international community could use to determine whether any course correction had occurred during the hidden passage, but perhaps most fascinating was the amateur response. Marcus Rodriguez organised what he called Operation Sunwatch, a global network of thousands of amateur astronomers who would monitor the sun's corona for any unusual activity that might indicate 3I/Atlas's presence. "We may not see the object directly," Marcus explained in a video that pulled 12 million views, "but we might detect secondary effects. If it's actively interacting with the solar environment, we'll see it. Every amateur telescope on Earth is now part of humanity's early warning system." The psychological impact of the blackout was measurable. Social media platforms saw explosive growth in discussions about what 3I/Atlas might be doing while hidden. Anxiety support groups reported increased membership. Some people found the uncertainty more stressful than actual confirmation of alien presence would have been. Religious communities organised prayer vigils and reflection gatherings. Many leaders interpreted the blackout as a test of faith, a period when humanity would be forced to trust in divine providence while remaining ignorant of events that might determine their future. Special services were held in churches, mosques, synagogues, and temples worldwide. Stock markets experienced wild volatility. Investors attempting to price in scenarios ranging from peaceful contact to existential catastrophe found no rational framework for valuation. Technology companies saw massive swings based on speculation about potential knowledge transfer. Defense contractors fluctuated as analysts debated the relevance of conventional weapons against physics-defying technology. But here's what really kept people up at night: the implications of intentional timing. If 3I/Atlas had deliberately positioned itself to encounter that coronal mass ejection back in September, and the evidence suggested it had, then it almost certainly had detailed knowledge of solar weather patterns, which meant the solar blackout timing might not be coincidental at all. Doctor. Robert Kim at Stanford analysed this from a strategic perspective. An advanced intelligence planning contact with a younger civilization would understand the psychological impact of periods of uncertainty. The solar blackout provides maximum leverage for psychological influence while maintaining operational security. The timing is too advantageous to dismiss as chance. Amateur radio operators maintained continuous monitoring despite the challenges. Some reported detecting subtle changes in background electromagnetic patterns during the first week of the blackout, nothing definitive, but enough to suggest that something might be active behind the sun. The final observations before 3I/Atlas disappeared showed continued structural development. New formations were emerging. The anti-tail configuration was becoming more complex, and electromagnetic emissions were intensifying. The object that would emerge from behind the sun might be significantly different from the one that entered. Dr. Lisa Park at MIT calculated what those 6 weeks represented in terms of potential activity. Based on the construction speeds we observed before the blackout, 3I/Atlas could theoretically complete substantial system modifications, deploy multiple secondary objects, or conduct extensive reconnaissance operations during this hidden period. The timescale is more than adequate for significant mission evolution. International space agencies established unprecedented information-sharing protocols for the blackout period. Any detection, no matter how minor or ambiguous, would be immediately distributed to all participating organizations. The cooperation represented a level of transparency that would have been impossible during earlier periods of international tension. But the cooperation was complicated by uncertainty about how to respond if contact actually occurred. No international frameworks existed for managing alien contact, and the urgency of the blackout had prevented comprehensive protocol development. As October turned to November and the weeks ticked by, humanity found itself in a strange collective state. Everyone knew something potentially momentous was happening behind the sun. Nobody knew what. The uncertainty created a unique form of global anxiety, what psychologists began calling cosmic suspension. Mental health professionals developed new frameworks for helping people cope with existential uncertainty on astronomical scales. The experience of collectively anticipating species-defining events while having zero information created psychological challenges that no previous generation had faced. And then, whispers began circulating through the amateur astronomy community. Small observations, subtle anomalies, hints that something might be approaching from the direction of the sun. Nothing concrete enough to confirm, but too consistent to ignore completely. The 6-week blackout was approaching its end. 3I/Atlas would reappear in early December, and the world would finally see what it had been doing during its hidden passage. But before it emerged, before we got answers about what might have changed, there was one more piece of evidence that made denial impossible. One final mathematical proof that 3I/Atlas wasn't just unusual, it was impossibly precise. And that precision, it told a story that no amount of skepticism could explain away. 6 weeks of wondering what 3I/Atlas was doing behind the sun was agonizing enough. But there was something even more disturbing that many people had overlooked in all the excitement about motherships and probe deployments, the route this thing had taken to get here in the first place. And when you actually do the math on that trajectory, the coincidence becomes so statistically impossible that calling it chance requires more faith than believing in aliens. Dr. James Chen at MIT had a problem. Not the kind of problem you solve with coffee and determination, the kind that keeps you staring at your computer screen at 3 a.m., double-checking calculations you've already verified 17 times. Because the answer you're getting is so improbable that it makes winning the lottery look like a daily occurrence. He'd been analysing 3I/Atlas's trajectory using data from 227 observatories worldwide. 4 months of observations, 4022 individual position measurements, the most comprehensive tracking dataset ever compiled for an interstellar object. And what he found made his stomach drop. 3I/8LAS wasn't just passing through our solar system. It was conducting a precision reconnaissance mission that would make NASA's mission planners weep with envy. The object was going to make close approaches to 3 major planets, Venus at 0.2 astronomical units on October 15th, Mars at 0.19 AU on October 3rd, and Jupiter at 0.36 AU on March 16th of the following year. Now, those numbers might not mean much to you, so let me put it in perspective. An astronomical unit is the distance from Earth to the Sun, about 93 million miles, so 0.2 AU is roughly 18.6 million miles. That sounds far, right? But in space terms, that's incredibly close. That's like driving from New York to Los Angeles and parking exactly 10 feet from your destination. Except you're travelling through 3-dimensional space at 124,000 miles per hour, and your parking spots are all moving targets. Chen calculated the probability that any randomly arriving interstellar object would approach these 3 planetary targets with the precision demonstrated by 3Y/ATLAS. He ran the numbers through every statistical model he could find. He had colleagues verify his methodology. He even rebuilt the analysis from scratch using different software to make sure there wasn't a coding error. The result, 0.005%. That's 0.005%. During the classified briefing at NASA headquarters, the one that later leaked to congressional investigators, Chen explained it this way. You're more likely to be struck by lightning while simultaneously winning 3 separate lotteries than to observe such precise planetary approaches occurring by random chance. This isn't statistical noise. This is impossible coincidence. But it got worse. The trajectory wasn't just precise, it was efficient. Each planetary approach was timed to maximize data collection while minimizing energy expenditure. The path allowed comprehensive surveys of each target while using gravitational assists to maintain optimal velocity. Dr. Sarah Mitchell, NASA's Director of Mission Planning, found herself in the uncomfortable position of admiring what might be alien engineering. This represents mission planning at a level exceeding our best capabilities. She admitted during internal NASA discussions that later leaked the energy efficiency, the scientific return optimization, the gravitational assist utilization. This demonstrates planning sophistication that suggests intentional design. Think about how we plan missions to other planets. It takes teams of specialists years to calculate optimal trajectories. The Voyager missions, probably humanity's greatest navigation achievement, required decades of planning to align planetary positions for these famous gravity assists. And even then, we were working with known destinations and predictable orbits. 3I/ATLAS had apparently planned a multi-planet survey of a solar system it had never visited before, executing approaches with precision that exceeded anything human technology had achieved, while travelling for potentially millions of years across interstellar space. But perhaps the creepiest detail was the approach vector. Unlike typical interstellar visitors that enter from random directions, 3I/ATLAS had arrived from Sagittarius directly toward the galactic centre, where the crowding of background stars made early detection nearly impossible. Dr. Maria Santos at UC Berkeley had modelled visibility conditions for objects approaching from different directions. Her analysis was damning. An object approaching from the Sagittarius direction remains effectively invisible until it reaches Jupiter's orbit. This provides only a few months of observation time before solar conjunction. The approach vector maximizes concealment while minimizing the window for detailed study. It was the signature of stealth. If you wanted to survey a solar system while avoiding early detection, This is exactly the path you'd choose. The timing analysis revealed even more sophistication. 3I/Atlas had arrived during a period of minimal solar activity, avoiding the intense radiation bombardment of solar maximum. The approach also coincided with favourable planetary alignments that optimised each encounter's scientific value. Chen's team modelled thousands of possible approach scenarios, testing different arrival times, vectors, and trajectories. Their conclusion was inescapable. 3I/Atlas had followed what amounted to the perfect path for studying human civilization while minimising detection time. Even the small details revealed sophisticated planning. The object's rotation period appeared deliberately selected to optimise solar panel efficiency if it was using solar power. Its structural orientation maximised gravitational stability during high acceleration manoeuvres. Everything about its motion suggested engineering rather than chance. Doctor. Robert Kim at Stanford analysed the trajectory using game theory and strategic planning models. His paper examined 3I/Atlas from the perspective of intelligence gathering operations, and the parallels were disturbing. The trajectory shows characteristics of a carefully planned reconnaissance operation. The approach vector, timing, planetary encounter sequence, and solar conjunction timing all serve to maximize information gathering while minimizing target awareness and response time. In other words, if this was a spy mission, it was a damn good one. Military analysts worldwide began treating the trajectory as a threat assessment. The precision navigation demonstrated capabilities exceeding human technology by significant margins, suggesting 3I/Atlas's creators possessed detailed knowledge of solar system dynamics and human space surveillance capabilities. The implications for security were staggering. If 3I/Atlas represented hostile intelligence, its trajectory provided optimal conditions for assessing human technological capabilities while avoiding detection until defensive responses became irrelevant. By the time we spotted it, the reconnaissance mission was already well underway. But here's what really haunted researchers: the journey duration. Backtracking 3I/Atlas's path through galactic space suggested a journey lasting potentially millions of years. Millions of years. Doctor. Lisa Park at MIT calculated what maintaining an active mission across such timescales would require. We're looking at engineering that treats million-year mission durations as routine planning considerations. This suggests either self-repair capabilities approaching immortality, or energy sources that can operate independently for essentially unlimited durations. The patience and persistence this represents is almost incomprehensible from a human perspective. Think about that for a moment. Recorded human history is maybe 5000 years old. The United States is 249 years old. The longest-running human institution, arguably the Catholic Church, is about 2000 years old. We struggle to plan projects that last decades. 3I/Atlas had apparently been travelling for millions of years to execute a survey mission of our solar system. The strategic thinking that represents planning on timescales that dwarf human civilization was almost as unsettling as the technology itself. Amateur astronomers had independently verified the trajectory analysis using publicly available orbital data. Multiple citizen science projects confirmed the mathematical conclusions, creating consensus across both professional and amateur communities. The democratization of the analysis made it impossible for authorities to dismiss the findings. Marcus Rodriguez summarized it perfectly during one of his live streams. The math doesn't lie. This thing plotted a course through our solar system that maximizes reconnaissance value while minimizing detection window. You can argue about intentions, motivations, or whether it's friendly or hostile. But you can't argue with the trajectory. Someone planned this. Someone incredibly patient, incredibly smart, and incredibly interested in us. The 0.005% coincidence had demolished the last refuge of skeptics who insisted 3I/Atlas might be natural. Natural objects don't execute precision multi-planet reconnaissance missions. Natural objects don't optimize their approach vectors for stealth. Natural objects don't plan million-year journeys with such meticulous attention to detail. And if the trajectory was deliberately planned, if someone or something had sent 3I/Atlas specifically to study our solar system, then every assumption about first contact, alien intentions, and humanity's place in the cosmic order needed immediate revision, because we weren't just being visited, we were being studied, systematically, professionally, by something with the patience to travel for millions of years and the technological sophistication to execute a reconnaissance mission that made our best efforts look like amateur hour. The question wasn't whether 3I/Atlas represented artificial intelligence anymore. The trajectory math had settled that debate. The real question, the one that was about to tear the scientific community apart, was whether that intelligence came in peace or represented something far more dangerous. So we had an object with impossible mass, physics-defying technology, and a trajectory so precise it could only be intentional. The scientific community should have been united in studying this historic moment. Right instead, they went to war with each other, and the battlefield a terrifying theory called the Dark Forest. Dr. Christopher Hayes had spent 30 years building a reputation as a calm, rational voice in astronomy. As chairman of the International Astronomical Union's Commission on Interstellar Objects, he was supposed to be the adult in the room, the steady hand that kept scientific discourse professional and evidence-based. By early October 2025, he was screaming at colleagues during video conferences. The scientific community wasn't just divided over 3I/Atlas. It was fracturing into hostile camps that questioned each other's competence, integrity, and sometimes sanity. And at the centre of this academic civil war was a concept borrowed from Chinese science fiction, the dark forest hypothesis. The theory goes like this: the universe is like a dark forest, where every civilization is a hunter moving quietly through the trees. You don't announce your presence because you don't know if the other hunters are friendly or hostile. The safest assumption, everyone's a threat. So you stay silent, hidden, and if you detect another civilization before they detect you, you eliminate them before they can eliminate you. It's basically cosmic paranoia elevated to survival strategy. Dr. Adam Hibbard at the Initiative for Interstellar Studies in London co-authored a paper that lit the fuse on this powder keg. Working with Avi Loeb and researcher Adam Kroll, Hibbard analysed 3I/Atlas's behaviour from the perspective of strategic reconnaissance rather than scientific exploration. His conclusion was chilling. The dark forest hypothesis suggests that any intelligence capable of interstellar travel would approach unknown civilizations with extreme caution and potential hostility. The behavior patterns we observe in 3I/Atlas are consistent with reconnaissance activities that precede either peaceful contact or preemptive elimination of potential threats. Preemptive elimination. Those two words triggered an academic meltdown. The paper outlined scenarios that defense analysts found deeply disturbing. If 3I/Atlas represented an advanced civilization that viewed other intelligences as existential threats, humanity might be facing evaluation for elimination rather than contact, the systematic survey of our planets, the assessment of our technology at Mars. The stealth approach vector, all of it could represent threat assessment rather than scientific curiosity. Dr. Margaret Thompson at NASA became the public face of institutional opposition. During a press conference carried on every major network, she stated firmly, "The suggestion that 3I/Atlas represents hostile alien intelligence is not supported by available evidence. Such speculation undermines public confidence in scientific methodology and represents irresponsible research. But here's where it got messy. Leaked internal NASA communications revealed that the agency was quietly developing contingency protocols for managing potential alien contact scenarios. Documents showed they were taking dark forest possibilities seriously enough to begin preliminary defensive planning. When those leaks hit the press, the credibility gap exploded. Scientists were publicly dismissing theories they were privately investigating. The hypocrisy fueled conspiracy theories and eroded trust in institutional science. Dr. Elena Vasquez, remember her from the original trajectory paper, found herself caught between competing pressures. The data suggests intelligence, but intelligence doesn't necessarily imply hostility. She explained during one of her increasingly rare appearances, "We must distinguish between evidence-based conclusions and speculative scenarios, though I'll admit the distinction is becoming uncomfortably blurry." The academic battle lines formed quickly. Younger researchers with less established careers tended to support open discussion of all possibilities, including hostile scenarios. They argued that ignoring potential threats for the sake of academic comfort was dangerously naive. Senior scientists with institutional responsibilities preferred cautious approaches, emphasizing uncertainty rather than specific threat assessments. They worried that dark forest speculation would trigger public panic and undermine decades of SETI research, built on the assumption that contact would be peaceful. Dr. Sarah Kim at Caltech tried to bridge the divide with a paper that satisfied nobody. "We are confronting intelligence that operates according to principles we don't understand. Attributing human motivations, whether hostile or benevolent, to such intelligence may be fundamentally inappropriate. We may be dealing with minds that think in ways that make our categories of friend and enemy meaningless." It was a philosophical position that acknowledged the problem while refusing to choose sides. Both camps accused her of fence-sitting. The debate took an unexpected turn when interdisciplinary researchers joined the fray. Anthropologists pointed out that first contact between human civilizations with technological disparities rarely ended well for the less advanced society. Psychologists questioned whether humans could even recognize alien hostile intent when they saw it. Philosophers argued that consciousness might operate so differently that human threat assessment frameworks were useless. Dr. Maria Santos at UC Berkeley, who had backgrounds in both astronomy and cognitive science, published a provocative analysis. "We are trying to understand minds that evolved under completely different conditions. The dark forest hypothesis assumes alien intelligence would think strategically about threats and opportunities in ways similar to human military planning. This assumption may be completely invalid. We might be as incapable of recognizing their true intentions as a dog trying to understand human poetry." Religious scholars added theological dimensions that further complicated the debate. Some interpreted 3I/Atlas as divine intervention, a test of faith or cosmic revelation. Others struggled with doctrinal implications of encountering intelligence that possessed near godlike technological capabilities. The Vatican's Pontifical Academy of Sciences issued a statement attempting to navigate these theological minefields. "The universe may contain forms of intelligence beyond human understanding. Divine creation encompasses infinite possibilities. However, fear should not overcome faith in providential guidance." But the real explosion came when military analysts entered the discussion. Colonel Janet Rodriguez at the Department of Defense published a declassified assessment that treated 3I/Atlas as a potential security threat regardless of intentions. Whether 3I/Atlas represents peaceful exploration or hostile reconnaissance, its demonstrated capabilities exceed our defensive systems by orders of magnitude, she wrote. Prudent security planning requires preparing for scenarios in which such capabilities might be used against human interests. The distinction between friendly and hostile becomes operationally irrelevant when the technological disparity is this extreme. The military perspective shifted the debate from philosophical speculation to practical preparation. If dark forest scenarios were even remotely possible, what should humanity do? Attempt communication, prepare defences, maintain silence, and hope we're ignored. Intelligence agencies worldwide began recruiting academic experts into classified analysis programs, creating a parallel research network operating outside peer review. This compartmentalization fragmented the scientific community further while reducing information available for public scrutiny. Some researchers refused to participate in classified work, preferring to maintain their ability to engage in open discourse. Dr. Robert Kim at Stanford publicly declined involvement in secret programs. Science functions best when information flows freely and conclusions can be challenged through open debate. The moment we start hiding analysis behind security classifications, we lose the ability to distinguish evidence-based conclusions from fear-driven speculation. His position attracted support from scientists worried about militarization of 3I/Atlas research, but also criticism from those who argued some aspects were too sensitive for public discussion. The academic warfare reached peak intensity when researchers began questioning each other's motives. Dark forest proponents were accused of fear-mongering and sensationalism. Skeptics were accused of naive optimism and institutional cowardice. Professional reputations were destroyed in journal article flame wars that read more like political attacks than scientific discourse. Twitter became an academic thunderdome where astrophysicists threw shade with the intensity usually reserved for celebrity feuds. One particularly brutal exchange between a Harvard professor and an IT researcher went viral, accumulating 15 million views and spawning endless memes about astronomical beef. But beneath the acrimony was genuine uncertainty about how to respond to a situation no human generation had faced before. We were potentially encountering intelligence that could manipulate fundamental forces, had travelled for millions of years, and possessed capabilities approaching the theoretical limits of physics. How should we interpret such an encounter? What assumptions were safe to make, Doctor? Lisa Park at MIT captured the philosophical vertigo many felt. We're using monkey brains evolved to navigate social hierarchies and avoid predators to evaluate intelligence that might view us the way we view bacteria. Our threat assessment frameworks may be as inadequate as a medieval peasant trying to evaluate nuclear strategy. Roar. The dark forest debate revealed something uncomfortable about human nature when confronted with cosmic uncertainty. We don't unite, we fracture. Every researcher brought their own fears, hopes, biases and assumptions to the question of what 3I/Atlas represented. And those differences, normally manageable in routine science, became unbridgeable when the stakes involved potential species survival. As October turned to November and the December deadline for potential probe arrival approached, the scientific civil war showed no signs of resolution. Both camps had mathematical support for their positions. Both had legitimate concerns about the implications of being wrong. And 3I/Atlas, oblivious or uncaring about the chaos it was causing, continued its relentless approach through our solar system. Soon it would emerge from behind the sun, revealing what it had been doing during those 6 hidden weeks. And humanity would finally learn whether the dark forest theorists were paranoid prophets or whether the optimists had been dangerously naive all along. But first, we had to survive the December deadline, the moment when Avi Loeb's calculations said any deployed probes would begin arriving at Earth. And as that date approached, even the most skeptical scientists found themselves looking at the sky with a mixture of wonder and dread. All the theories, all the arguments, all the mathematical models and philosophical debates, they were about to collide with reality. Because November 21st had arrived, the window was opening, and whether you believed in motherships, dark forest scenarios, or peaceful scientific exploration. Everyone on Earth was about to find out if Avi Loeb's math was prophecy, or just really unfortunate timing. November 21st, 2025. If you'd told me a year earlier that I'd be watching the calendar with the same anxiety usually reserved for medical test results or election nights, I'd have laughed. But here we were, an entire planet marking a date that could represent either humanity's greatest moment or its last normal day. Doctor. Sarah Kim at Caltech hadn't slept properly in weeks, not from excitement from the mathematical precision of what might be about to happen. The orbital mechanics are unforgiving, she explained during what had become daily briefings for government officials who looked increasingly like they'd rather be anywhere else. If 3I/Atlas deployed probes during its solar passage, physics dictates they'd begin arriving in Earth's vicinity during the next 2 weeks. The math doesn't care about our readiness. Think about that for a moment. We had a deadline, an actual date when alien technology might arrive, not someday or eventually or maybe never. November 21st through December 5th. Circle it on your calendar. Humanity's potential first contact window. Brought to you by Newtonian mechanics and one very controversial Harvard professor. The psychological impact of having a specific timeline was unlike anything social scientists had documented before. Stock markets experienced volatility that made the 2008 financial crisis look stable. Religious communities organised continuous prayer vigils. Preppers cleared out survival gear from retail stores, and millions of people worldwide found themselves checking the sky more often than their phones. Marcus Rodriguez had transformed his amateur astronomy network into something resembling a global early warning system. 4,000 active observers across 87 countries, coordinating 24/7 sky surveillance, with the intensity of people waiting for test results that would determine everything. We've become humanity's eyes, Marcus explained during a livestream pulling 2.3 million concurrent viewers. Every amateur telescope on Earth is now part of a detection network. If something's approaching, we'll see it. We have to see it. Because if we don't, who will? The question hung there, heavier than anyone wanted to acknowledge. NASA and other space agencies had mobilized every tracking asset they possessed. Military surveillance networks designed for monitoring satellites and debris were reconfigured to detect small objects approaching from interplanetary space. The challenge was enormous. Any probes from 3I/Atlas would likely be smaller and more advanced than anything human systems were designed to identify. Doctor. Jennifer Walsh at the Space Telescope Science Institute coordinated what she called the most intensive object search in human history. Every major telescope on Earth and in orbit was scanning, searching, hoping to spot something before it got too close. But nobody really knew what too close meant when dealing with technology that could manipulate fundamental forces. The detection challenge was terrifying when you thought about it. Human spacecraft are large, relatively crude objects creating obvious signatures. Alien probes, if they existed, might be small enough to avoid detection while possessing capabilities that made our surveillance systems look like security cameras from the 1990s. Intelligence agencies worldwide activated protocols that had been theoretical exercises just months earlier. The European Space Agency quietly repositioned monitoring satellites, burning precious fuel to maximize coverage of approach corridors Loeb's analysis had identified as most likely. Dr. Angela Martinez, coordinating ESA's efforts, couldn't hide a concern. We're attempting to detect objects that may be smaller than cars, travelling at interplanetary velocities, using technology that exceeds our understanding. Our detection capabilities may be fundamentally inadequate. That was the subtext everyone was dancing around. We might not see them coming, even if they wanted us to. Colonel Janet Rodriguez, writing classified assessments for the Pentagon, didn't mince words in documents that later leaked. We are potentially facing intelligence operating on million-year timescales while possessing technology approaching theoretical physical limits. Traditional concepts of negotiation, deterrence, and defense may be completely irrelevant when dealing with such vast capability differences. The religious response varied wildly. Some leaders saw the December deadline as divine revelation about to transform humanity's understanding of creation. Others worried about spiritual implications of encountering intelligence that might challenge fundamental doctrines. The Vatican issued statements preparing Catholics for possibilities traditional theology had never seriously considered, emphasizing that divine love encompassed all creation regardless of origin or technological capability. Educational institutions faced an impossible challenge. How do you prepare students for a future that might be fundamentally different from anything in human experience, Dr. Maria Santos at UC Berkeley developed curricula focused on adaptability rather than specific knowledge that might become obsolete overnight. We're teaching cognitive flexibility, she explained. How to think about unprecedented change rather than what to think about established facts. International cooperation reached levels that decades of diplomacy had failed to achieve. China shared surveillance data with Western agencies. Russian space assets coordinated with NATO systems. The possibility of alien contact had temporarily created unity of purpose, transcending terrestrial political divisions. But cooperation was complicated by uncertainty about response protocols. No international frameworks existed for managing first contact. Should we attempt communication if something arrived, maintain defensive postures? The urgency of the deadline had prevented comprehensive protocol development, leaving humanity to improvise during what might be the most important moment in our species' history. Amateur radio zoo operators reported increased activity in frequency ranges that had previously shown only background noise. The signals were too weak for definitive analysis, but their timing coincided with Loeb's deployment scenarios in ways that prevented easy dismissal. Marcus Chen's network documented subtle electromagnetic patterns that might indicate something approaching or might just be wishful thinking projected onto cosmic static. Social media platforms experienced unprecedented activity. Billions of people worldwide sharing theories, fears, preparations for what might occur during the contact window. The psychological impact created what mental health professionals called cosmic suspension, collective anxiety about species-defining events coupled with complete inability to influence outcomes. Online communities dedicated to 3I/Atlas tracking grew to hundreds of millions of participants following developments in real time. The democratization of information created global conversation operating outside traditional institutional channels. Governments couldn't control the narrative when thousands of amateur astronomers were independently verifying or contradicting official statements. As November progressed toward December, telescopes maintained vigilant watch while human society held its collective breath. The deadline represented more than just a date, it had become a focal point for humanity's hopes, fears, and assumptions about our place in the universe. Then, on December 2nd, something happened that made everyone's breath catch. 3 amateur astronomers, one in Chile, one in Australia, one in South Africa, simultaneously reported detecting a small object moving against the background stars, not following typical asteroid trajectory, not behaving like space debris, moving with purpose, moving toward Earth. Marcus Rodriguez verified the observations within 30 minutes. His voice during the emergency livestream was steady, but you could hear the weight of what he was saying. "I've confirmed the detection. Object is approximately 2.3 million miles out, approaching at variable velocity. Trajectory suggests intelligent guidance. This is not natural. Repeat, this is not natural movement." NASA's tracking systems picked it up 47 minutes later, then the European Space Agency, then Russia, then China. Everyone was seeing the same thing, something small, something moving deliberately, something that hadn't existed in that region of space 24 hours earlier. Doctor. Sarah Kim's analysis confirmed what everyone was thinking, but nobody wanted to say out loud. Object demonstrates trajectory corrections inconsistent with ballistic movement. Observable acceleration changes suggest active propulsion. Based on current velocity and vector, Earth intercept in approximately 72 hours. 72 hours. 3 days until something that had apparently been deployed by 3I/Atlas exactly when and where Avi Loeb predicted would reach Earth's vicinity. The next 3 days were the longest in human history. Governments activated emergency protocols. Military installations went to alert status. Communication networks were hardened against potential electromagnetic interference. And billions of people worldwide found themselves asking the same question: what happens when it gets here? On December 5th, the final day of Loeb's predicted window, the object entered Earth's orbital space. Not aggressively, not threateningly. It simply arrived, taking up position approximately 250,000 miles out, roughly the distance to the Moon, and stopped. It had been broadcasting signals the entire approach. Structured, mathematical, clearly artificial. SETI researchers worked frantically to decode them, but the mathematics involved were unlike anything in human experience. It wasn't trying to communicate in ways we'd anticipated. It was demonstrating capabilities, showing us what it could do, and 3I/Atlas right on schedule. It emerged from behind the sun in early December. Every telescope that could point in its direction immediately locked on. And what they saw made everything that had come before seem like a warm-up act. The object that reappeared was different, significantly different. New structures had emerged during the blackout period, massive, geometric, clearly technological. The anti-tail configuration had evolved into something far more complex. Electromagnetic emissions had increased by orders of magnitude. Dr. Jennifer Walsh, analysing the first post-blackout images, said what everyone was thinking. Whatever it was doing behind the sun, it's finished now, and judging by these modifications, it's ready for the next phase of whatever mission it's conducting. Avi Loeb's mothership theory wasn't speculation anymore. It was documentation. We'd just watched the deployment phase of what appeared to be a systematic survey mission. One probe, possibly more we hadn't detected yet, was now in Earth's vicinity. The mothership had completed its modifications and was continuing its trajectory toward Jupiter. Humanity had survived the December deadline. But survival didn't mean safety. It meant we'd graduated from unaware to under observation. The probe near Earth wasn't threatening. But it wasn't leaving either. It was watching, studying, gathering data about human civilization with technology we couldn't begin to understand. The verdict on 3I/Atlas was no longer in doubt. Natural wonder or alien arrival, the math had spoken. The observations had confirmed it. We weren't alone in the universe. And whatever had sent 3I/Atlas to study us possessed technology and patience that made our greatest achievements look like children's drawings. The real question, the one that would define humanity's future, wasn't whether we were being visited anymore. It was what they wanted, what they'd learned about us, and what they planned to do with that information. Because somewhere out there, millions of years and light years away, something had decided we was worth studying, and judging by the technology it had sent to do that studying, it could probably decide we were worth a lot of other things too. Sweet dreams, everyone, and maybe keep one eye on the sky tonight.